This is pre-algebra lesson 9-5, congruence. Congruent figures are figures that have the same size and shape, as well as corresponding parts, sides and angles, have equal measures. It's basically like a photocopy of the original. Same size, same shape. Tick marks are used to indicate that segments are congruent, and arcs are used to indicate that angles are congruent. Remember, I've used these before, the same number of slashes to a side. I prefer to use one arc and then tick marks to an arc to indicate angles are congruent. This is what's used in many geometry texts, and it's easier to use on a smaller figure. However, both ways are fine, and I'll explain what that means in just a minute. To write a congruent statement, you must list the corresponding angles in the same order. For example, if I told you that triangle ABC was congruent to triangle EBF, okay? ABC is congruent to triangle EBF. It has to be in that order because if you look at this, I went from A to B, so I have to go E to D. Then I went from B to C, so I have to go D to F. And last but not least, I went C to A, so I have to go F to E. They have to go in the same order. Okay, so it has to go E, D, F. Angle A is congruent to angle E. That's what I mean by putting an arc and a tick mark. Some books use this. They'll use one arc or two arcs to say that these angles are equal. I don't like the two arcs because it gets a little hairy. Okay, so I'm just going to erase all the stuff I have on here, and I'm just going to say angle A is congruent to angle E. Angle B, I like that way better, is congruent to angle D. And angle C is congruent to angle F. Side AB, this side here, is congruent to side ED. Side BC is congruent to side FD. And last but not least, side AC is congruent to side EF. So there we have congruent sides and congruent angles. And that would make those figures be congruent. In order to be congruent, they have to have all the matching parts must correspond. I couldn't say that angle A is congruent to angle D because they are not. So you have to match up the parts. Now, when two triangles are congruent, it is often easier to see their corresponding parts if you sketch the two triangles side by side facing the same direction. That's just a big hint that makes it a little bit easier to figure out what you're doing. Okay, you can use corresponding parts of triangles to identify congruent triangles. Below are 3 ways that you can show that two triangles are congruent. You can show that they are congruent by side, 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 which means the 3 matching sides pair up. Like, for example, I will say that this side matches with this side here matches with this side here, and this side here matches with this side here. That's called side, 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 otherwise known as SSS congruency. You can have side, angle, side congruency. Side angle side congruency means you have 2 sides and the angle is sandwiched between the 2 sides, kind of like an Oreo cookie. If you were going to read around the triangle, if you're going to start at this vertex and go all the way around like this, you would have a side. The angle would be between the side, and then you'd have another side. The angle has to be between your 2 congruent sides without skipping an angle or skipping a side. So that would be called side, angle, side. And it doesn't matter what sides or what angles as long as they go in a row. Notice here I have, I mean the side, then the angle, then the side. Side, then angle, then side. I go in order around my figure. You can also have angle, side, angle. Angle, side, angle means the side is sandwiched between the angles. And it doesn't matter which angle I start with or which side. I can say this is angle, this side here, and this angle there. So that to be congruent, we have to be this angle, this side, and this angle. Okay, that's called angle, side, angle. The side is sandwiched between the 2 angles. See, this side here is between my 2 congruent angles. Where here, this angle was between the 2 congruent sides. And now we're going to go to identifying congruent parts in a figure. Here we have this figure here. And it says identifying congruent parts. In this figure, TUV is congruent to WUX. If you don't want to draw them facing the same direction, which a lot of people don't like to do, they don't like to redraw them. I actually like to redraw them because I'm dyslexic, so it's really easy for me to flip things anyway. So it's really easy if I actually draw it. I have TUV facing this way. Here's TUV. TUV just like this. What I would do is I would draw another triangle next to it, same direction, okay, like this, because TUV, it says right here, it says right over here that TUV is congruent to WUX. So if TUV is congruent to WUX, this would have to be W, this would have to be U, and this would have to be X. So there I have my two figures. I have T is congruent to W. TU is the side, congruent to W here. And then I have the angle U is congruent there, so I basically have them congruent by angle, side, angle. I've got them congruent because they say they're congruent. So let's name the corresponding congruent angles. So now that I have them facing the right directions, I know that angle T is congruent to angle W. I also know that angle U is congruent to angle U, because they share that same angle in both figures. And I know that angle X is congruent to angle V, or Vx. Another way of looking at this, okay, is I can look at this and I can look at the letters themselves. T is congruent to W because they're labeled first. U is congruent to U because that's the middle letter. And last but not least, V is congruent to X because that's the last letter. They have to go in order, they have to match. Which means now I can name my congruent sides. If I didn't even draw my figure, I should be able to name my congruent sides. Because here, my congruent sides, if I looked at the figure, the congruent sides of TU is congruent to WU, right? Which it is. If we look here, TU is congruent to WU. And I just look here, TU is congruent to WU here. I can have UV is congruent to UX. Okay? UV is congruent to UX, and last but not least, TV is congruent to WX. And I can either use the label of the figures, or I can use the figure itself. Okay. Now, what's the length of WX then? Well, if the length of TV is 300 meters and these two figures are congruent, okay, since TV is congruent to WX, TV equals 300 meters, therefore WX has to equal 300 meters because they're congruent. Alright, simple as that. Now we're going to identify some congruent triangles. This is probably a little bit harder of a concept to understand. It says we're going to list the congruent corresponding parts of each pair of triangles, and then we're going to write a congruence statement for the triangles. So you're going to do a lot of this when you finally get into geometry class at a much higher level than this. These are basic, simple congruent statements. Now, for these two particular triangles, it's probably going to be easier for me to separate them. If I look, the thing I should pay attention to is I should pay attention to the very last statement here. It tells me triangle such and such, triangle blank is congruent to triangle LJK. So if I look at my figure, LJK goes that way. So I'm looking at that big triangle there, which means I have to be comparing that to this big triangle over here. This is what we call overlapping triangles. They share some parts. And it's very, very easy to get confused with these overlapping triangles. So I'm going to separate them. I'm just going to draw them. I'm just going to sketch them right up here, right above, so that I can keep track of every part. So this is J, and this is K for both triangles. All right, because they both share JK right down here. This is M here, and this is L here. Now I'm going to mark what I know. It tells me here that angle J acute angle J, see this a small acute angle J here is congruent to this small acute angle K here. Okay. It tells me side MK, okay, because it tells me MK here is congruent to JL here. Okay, so that's what we have marked on my figure. So it says that LJ is congruent to, we already figured that out, LJ is this part right here, and it is congruent to its counterpart. So LJ, which is this part right here, has got to be congruent to MK right there. So I'll write that down. LJ is congruent to MK. And angle LJK. Angle LJK is congruent to angle MKS. Because if I look at my figure, I go LKJ, or excuse me, LJK. That's the angle with the one little hash mark through it. The only other angle that has the angle with one little hash mark is MKJ. So this would be angle MKJ. And last but not least, JK is congruent to itself because they share the same side. So this is JK. So if I was to name the triangles, I have to make sure I name these in the right order. It goes LJK. So if I started up here, and let me use green here. If I go from L to J to K, I have to go from M to K to J. Okay? So LJK has got to be congruent to MKJ. And it has to be in that order because otherwise you have the congruent parts out of order and they're not congruent. And they're congruent by, if you look at it, they share this bottom side down here, don't they? So they're congruent by side angle side. That's one of the congruency conjectures we talked about with the congruency statements. The angle is sandwiched between the two sides, so side angle side. Let's take a look at another one, because these are sometimes a little bit difficult to understand. ABC. Okay, let's look at our figure, ACB, excuse me. I have angle ACB, that would be this angle right here. That's got to be congruent to this angle right here. So that would be ECB. That's angle ECB here. AC, that's this figure right here. AC is congruent to EC. And don't forget all the little symbols that you need because there's segments and angles and everything. CAB, angle CAB. I'm going to use a highlighter for that one. Angle CAB has two little hash marks through it, so that's got to be the CEB. So that's angle CEB. Now, if we look at this, it's saying triangle ACB. So triangle A, we go from A, then to C, then to B. So that's the angle 2 through the side that has 1 through the 1. So I have to start 2 through the side that has 1 hash mark to the other angle. So that would be ECB. This is ECB. And they are congruent by, it looks like a side is sandwiched between two angles. So that would be angle side angle. Let's go through one more. So these are a little bit more difficult to do. These are lovely figures. They're all sides are marked. So F to J. F to J. If I look through this, F to J goes through the side that has 3. So that has to be through the side that has 3. So that would be F to G. F to G. J to I. J to I is going through the side that has 1. So that would have to be, since I'll start it, it started from J, which is connected to the yellow, so I'll start from G, which is connected to the yellow, so it would be GH. So here is GH. And then FI, starts at F, goes to I. That's just the last side left. F to I has to be congruent to F to H. Therefore, my triangle, if I look at my triangle, I'm going J, F, I. So through the yellow side, through the blue side. Okay, so I have to start with the side. I have to start with the angle that's between my green and yellow highlighter. So that would be, if it's angle J here, I have to start with angle G here. So that would be G. Then they went to F. So they went this way, so I have to go this way. So it would be G, F, and the only letter left is H. And what are they congruent by? All three sides seem to be the ones that are congruent. So side, side, side. Congruence. You'll do a lot of this when you get into your formal geometry class, but this is just an introduction. And it just says that basically the parts match, and you have to match up the proper parts. If I photocopy something, but turn it around and flip it over, it's not going to match until I get it facing the same direction of which it came out of the photocopy.